What is up, everyone? Today I wanted to make a quick video on this latest supply chain attack. I want to start with, most importantly, right away, how can you tell if you're affected? Are you impacted? First, if you don't do anything with crypto, if your website doesn't accept crypto as a payment, if you're not showing crypto wallet IDs anywhere in your application, then you are probably fine at this point. The attack was very specific in terms of targeting swapping crypto wallet IDs and sending transactions to an attacker crypto account. And so basically, you are safe from this specific attack, but keep watching if you want to learn more about how it worked, what it was about. If that doesn't apply to you and you really need to figure out if you were affected, then it's hard to tell exactly when the libraries were taken down over time, but essentially you have this list of packages that I've linked below with specific versions that were impacted. And you need to check if during the window from which these were attacked, which was about 9 a.m. Eastern to about, they started getting taken down within about 3 hours. But then some of them took longer to take down. So about 2 p.m., 3 p.m. Eastern, all of these packages were taken over. Some of the most popular ones were only malicious for about an hour or so. Some of the other ones took longer to get updated for reasons we'll talk about. But you need to check if your application deployed any of these versions during that time. And that can be kind of challenging to do, because a lot of the times this is transitive dependencies that are happening within your application. So even if you look at your package.json for these, one quick way to check would be if you are not doing what I'm doing here, which is auto updating to the latest minor version, then you know that you're okay because you've pinned all of your dependency versions to known good versions. But if you are doing something like this or using the tilde in here, then you know that you could be affected because you would automatically grab the latest patch version, and untangling that transitive dependency web can be really difficult. You probably already have an SCA tool for it that you can check, but I've also included a couple of handy commands here. One is using a rip command that was in the Hacker News forum, as well as a GitHub issue, to look for a piece of the malicious code. The other is to list for what versions of the packages you currently have. But again, the issue here is this will only show what's currently installed. It won't show what was installed during the time of the attack. Some other IOCs you can look at are the phishing domain. Probably won't help you very much because this was targeted specifically against the maintainer. But all of the crypto wallets are here. And so depending on the amount of logging that you have, you can look for transactions that are tied to these crypto wallets to try to see if you have any transactions that occurred during the time period that were from multiple different users, indicating some sort of compromise was affecting them. Another thing you could do just to check or if it's faster is redeploy. Now that these versions have all been taken down by NPM, a redeployment would fail to find these versions because they're no longer available. And so here you can see the version was 0.2.1 of /, and now it's back to 0.2.0. And you can see the published state went back to 9 years ago. Earlier today, this all looked like 1 hour ago, 2 hours ago, because it was all this morning. So that's the super quick TLDR if you have no time on what to do, if you're impacted right away, to figure it out. But then let's actually talk about, let's start with what the attack did. And the storyline of the attack came out later. Luckily, the maintainer here is on Blue Sky, and Josh was incredibly helpful throughout this process and super communicative, letting us know exactly what happened. He even shared screenshots of the phishing attempt that was successful and was just super open about trying to contact with NPM, how long they had installed, what they were doing. Luckily, he had a co-maintainer that was deleting some of the malicious packages while he was locked out of his NPM account, unable to get in, and waiting for NPM to respond. Now we can start with the phishing email that detected. Just to get an idea of what this phishing email looked like, you can see it showed up as a verified email from this npmjs.help. Obviously, you'd have to be paying some close attention to that. You know, this was early in the morning. He said he just was dealing with a lot and just went through and started approving things. And here was the first clue that this was phishing. Then he went through to update his 2FA, logged in, and his credentials were compromised. What's insane to me about this is if you notice this was 2:50 a.m. his time, is how fast this attack actually happened. So basically this was about 10 hours before the actual attack. But now let's take a quick look at the code itself that was run. So essentially you had all of these hard-coded crypto wallets in here, and all of these wallet addresses were used essentially to first look if a user wallet in a request looked similar to it, and then it would find the closest from this list to obfuscate and send back to the user, and I'll get a little more into those details. But this is really smart because most people do not have these wallet addresses memorized. And so swapping them out for something that looks similar would trick most users. So the way that the attack actually worked was, say I deployed this compromised package. Then when the user's browser runs this fetch command to interact with an application, say it's a large cryptocurrency exchange, and I'm logging into my account and I click to view my wallet. This package then first looks at this fetch data, checks if it has any regexes that match a regex for a crypto wallet. And if it sees the wallet address, it swaps it out and returns it to the user. So if a user is looking to send crypto to someone, or is even looking at their own wallet to manage it or to copy paste it, send it somewhere else, it's going to exchange that silently with the attacker's wallet. So that was one thing it was doing. The other optional piece was that if it sees the Ethereum send transaction function, it'll automatically, instead of doing send transaction with the user's wallet, it'll swap it out at that point and just go directly to the attacker's wallet. So this is a really brilliant sort of silent attack that would have gone unnoticed, except it was detected by a few different systems. It seems this JD user detected it. It seems that Socket detected it. It seems that Aikido detected it. And really, I'm happiest about Aikido and Socket detecting it because they do this upstream malware scanning where every time there's a commit that happens, I understand that, including that and GitHub issues and different feeds they're looking at, they're asking LLMs to determine if there's indicators of compromise, and if they are, they escalate it for review. And so honestly, Aikido was able to detect this. I think it was within an hour of when the uploads happened based on me doing the math, but either way, it's incredibly fast that they were able to detect and let everyone know, hey, this has been compromised. And then within a few hours, the malicious version started getting taken down of these NPM packages. All right, so now let's back up and do some high-level thoughts about what prevents this. Now, I've complained before about the fact that this is ultimately really challenging because vulnerabilities are fundamentally different from malware, right? This isn't, if you're using this version, you might get exploited, hurry up and patch to the latest version. This is an instance of, because you're on the latest version, you are getting attacked. And if you deploy this, you've been compromised. And honestly, luckily in this case, the attack was sort of targeted at very specific crypto users. And so specifically anyone who runs a site related to crypto needs to really check their logs and deployments to see if they deployed these malicious versions. But how do you stop these things, right? Because time a vulnerability gets published, right, most of the way in-scanner pipelines work, and here's just a screenshot of deployments, usually you run a security test here. And when you run like an SCA scan that looks for vulnerable dependencies, that's only going to be updated in the best case a few hours, if not, if you're using an older vendor, probably days or weeks after the fact. And these versions are only going to be added to the detection. And even many teams are not automatically failing builds when they detect vulnerable package versions, which is something that I honestly don't usually recommend that you do, because normally you only want to block if a developer is actively introducing a new vulnerability. And even then, there's other things to consider as far as, is there a fix available? How important is the inset? What's the likelihood of the vulnerability? So in general, I don't even recommend blocking builds depending on the specific circumstances of what's there. But even if you were blocking builds on vulnerabilities, right, this wouldn't necessarily detect it until after the database gets updated. And by the time the vulnerability database is updated, the malicious packages are probably already taken down. And so you really haven't done much. The only way to actively detect and prevent this is twofold. One is not using sources like NPM for your build. And so there's a couple solutions out there that are focusing on secure build pipelines. One is a company called Step Security that's doing pipeline hardening. Another is ChainGuard is trying to create a safer stream for all of these packages. But at the end of the day, right, these tools still will miss some things, but it's a step in the right direction. Similarly, Aikido and Socket, for example, both offer NPM wrappers where if it detects a malicious version, when I try to NPM install my packages here, it would use their NPM wrapper instead, and it would look for, hey, you have a malware version. We're not going to actually let that install run. And unfortunately, none of these are really good solutions. The NPM wrapper is the closest to a good fix because someone like Aikido or Socket are updating their databases really quickly, right? They're the ones who are detecting this stuff. And so the NPM wrapper is a decent way to stop it. Additionally, if they're flagging it in their build tools as malware, and then you can actually flag to fail on malware. So then let's talk about, for this specific attack, if there's any runtime technology that would have stopped it. And unfortunately, this is a blind spot for every tool that exists, right? Because this is getting deployed to the front end in a obfuscated way. So it's living in the user's browser. and then it's silently swapping the addresses out and then sending it to the user. So only if you had some advanced detections where you were tying crypto wallets to users, which is its own potential data issue, would you be able to spot something like this happening? Because at the API network level, the backend data would all look exactly the same or as normal. So yeah, this is a really scary and smart attack that was very targeted and had a quick turnaround. Thankfully, the maintainer was on top of it, right? Like if he was out having a sick day, that would not have been a fun time for anyone. So in short, if you're in a high security environment where you can't afford to let these things happen, don't do what I'm doing here. Make these forced versions. And honestly, you have to take a Windows patch management strategy that's very familiar to security professionals and apply it to the Linux and open source world, which is really, really challenging, right? Because normally in a Windows environment, for example, it's pretty well defined that every month on Patch Tuesday, you have a control group of systems that contains samples of all your different endpoints. You run the update to the patches, you monitor those systems for a week, 2 weeks, and then you roll out that patch to the rest of your fleet. In these use cases, though, setting a patch management cadence is really challenging for your org to figure out what's the right pace at which we update these things. And then, yeah, the trade-off between just really thinking about how often do we want to update. There's a lot of ways you could tackle that. You could do something like this and use an internal NPM resolver. So imagine you copy all your open source dependencies, host them in-house, have a allow list of approved packages, set them to auto update like this, but then you control when those packages get updated at your internal registry. That's one way to approach it, but it creates a lot of administrative overhead. The alternative is pinning all of your versions and doing updates when needed, but that creates the patching overhead. And really, yeah, this stuff is a massive pain to deal with. Some other solutions that exist out there are like Endor Labs tries to let you know the difficulty that a patch is going to bring with it by looking at the function changes to see if you're using any of the impacted functions. But that library support is not universal. It doesn't cover everything, and it still requires developers to do work. It's not free. And so really there's not, in my opinion, like a great, perfect solution to this besides, a lot of the issue lays on the upstream maintainers, on people like these organizations that are underfunded, having incident response teams that can move really quickly when this stuff happens. And GitHub's been pretty good about it. NPM in this case was okay about it. It took a few hours, but they got there. And, another common criticism is that NPM JavaScript development is kind of busted, right? Because you have all these very small libraries with huge amounts of downloads. They're all really old and doing very simple things. And so if you don't need to use a library, don't use the library is another piece of advice that you will receive quite often. Something I didn't talk about with this that also makes it scary is the amount that these tools are transitive dependencies, which means debug especially is super widely used. And if you're using this tool, you might be using a package that relies on these other packages as a transitive dependency. And if these functions are getting imported, then you're being affected, even though these don't show up at all in your package. Final, rather ominous note is that other maintainers have been affected. We saw this with this latest proto tinker issue. And so the attack still seems to be ongoing. It's possible other maintainers got the same spear phishing compromise done to them. Yep. So this was a crazy one. And one more reason that open source is really scary.